Use the graph at the right to answer the following questions. Is g of x a function? Okay, सबसे पहले हमने देखना है if g of x is a function or not. So for the function we need to do the vertical line test, and vertical line test says us that I have to draw a vertical line anywhere and it should meet the point at one point. I will draw a vertical line here, it will meet the graph at the one point. Vertical line here, it will meet the graph at one point. Vertical line here, it will meet the graph at one point. So this function g of x passes vertical line test, so therefore yes, it is a function. Because it passes vertical line test. Now, is it 1 to 1? So we need to know that is it passes horizontal line test. So we know that it does not pass horizontal line test, because when we draw a line over here it crosses more than one point. So no, because it fails horizontal line test. Okay, state the domain of this graph. So what will be the domain of this graph? Domain is all the x values on the graph. So graph is going towards here, it is going towards negative infinity, and towards here it is going towards positive infinity. So the domain would be negative infinity to positive infinity. Range are all the y values. The graph is going downwards towards infinity, negative infinity, and to upwards it is stopping at 8, and 8 is not included. So from negative infinity to 8, where 8 is not included. State the interval g of x is increasing. Increasing means going upward, so it is going upward from here to here. This is the point where the graph g of x is decreasing. So first question is for decreasing, so it is decreasing from here to here. This is the line where it's decreasing, starting decreasing from -2, and it will from to 0, -2 to 0 union. It is decreasing from here to minus infinity, and this point is 2. So 2 is not included, to minus infinity. This is the point and this is 3. Okay, state the interval g of x is increasing. This is about decreasing. Now we will state the interval where g of x is increasing. So for increasing we have 0 is included, to this point is 3. So 0 to 3, and 3 is not included, 0 is included, and 3 is not included. Because in the interval g of x increasing decreasing, we're going to look the x-axis values. Okay, if the state the interval g of x is constant from here to negative infinity, -2 to negative infinity, and -2 is included. Relative maximum. Okay, what is the relative maximum? The maximum values. So is there any maximum value that exists? No, so it does not exist. What is relative minimum? The minimum value would be 0. Absolute minimum, any minimum which is absolute, no, does not exist, because it's going to negative infinity. And absolute maximum, and absolute minimum also does not exist. Okay, the next question is g of 3. G of 3 is equal to, this is the close point 3. G of -10 does not exist. G of -8, -9, -10, it is all going in the straight line, that is 1. G of 2 will be equal to 4. Where is g of x is equal to 3? G of x is equal to 3. At x is equal to 1.8, -1.8, and 3. 1.8, -1.8, and 3. Where is g of x greater than 0? Means g of x is greater than 0 means that is g of x is above the x-axis. So it's greater than 0 from -infinity to 0 and 0 to 3. Okay, what do these functions have in common? Which one doesn't belong? So let's find the domain first of all. But it will be the domain of the a, because it's going over here and going over here, so it would be from positive infinity to negative infinity, that is real numbers. So we can see one other thing over here, that we have the symmetry. Okay, the a has, you can see that a has a symmetry along y-axis, because the same thing over here and the same things along the y-axis. So a has symmetry along y-axis. B is again the same thing, symmetry along y-axis. C, symmetry along y-axis. D does not have symmetry along y-axis. E, yes, it do have symmetry. F. So A, B, C, E, F have symmetry along y-axis. Therefore, D is different. Why do these functions have in common which do not belong? Okay, so 1 has a symmetry along the origin. 2 does not have symmetry along origin. 3 has symmetry along origin. 4 has symmetry along origin. No, 4 does not have symmetry along origin. Yes, 5 has symmetry and 6 has symmetry. So 1, 3, 5, 6 has symmetry along origin. So the answer for this is 2 and 4 are different. Okay, now coming to even and odd functions. If a function is symmetric with respect to the y-axis, it is even function and f of x is equal to f of minus x. If a function is, this is f of x, it is symmetric with respect to y-axis, that this is the y-axis. So the part of the function that is along this side is same along this side. It means if I have a function x axis, this is x-axis and this is y-axis. So I have the same part of the function here and the same part of the function here. So if the function is symmetric along y-axis, then such a function is called even function. If a function is symmetric with respect to origin, it is an odd function. So this is an origin, the function is coming here in the origin and here in the origin. So it is symmetric along the origin, equal distance from the origin to the left side and the right side. Then this is called symmetric along, the function is odd. Most functions do not have any symmetry and are therefore neither even nor odd. Okay, use symmetry to decide if each of the following functions are even, odd, or neither. Okay, so if the function is going to have symmetry along the y-axis, it's going to be even. If the function is going to have symmetry along origin, it's going to be odd. Okay, so let's check. This is origin, it is going 1 and 1.5 box downwards, so it's going 1 and 1.5 box upwards. Then similarly it's going here and go here, so yes, it is symmetric along origin, so it's odd. Now this one, this is not is it symmetric? 1 2 and the third box has the line 1 2 and the third box has the line from bottom. The distances are equal on the both sides, so this is even because symmetric along y-axis. Now this is not symmetric along y-axis and neither with origin, so it is neither even nor odd. Okay, this is not symmetric along y-axis and neither about origin, so not neither symmetric. Okay, this is same along here and same here, even. This is origin, odd. This is same on the both sides, even. This is 1 2 1 2 3 4 and only 2 are in the bottom, so it is neither because the distances are not equal. This is 1 here, 1 here, even, or odd. Even means same, 1 box 1 2 1 2, but it is not symmetric along the y-axis, so neither. Okay, to verify algebraically whether a function f of x is even or odd, compute f of minus x and compare the results to the original f of x. A function is even if f of negative of x is equal to f of x for all values of x. A function is odd if f of negative of x is equal to minus f of x for all values of x, and f of negative of x is not equal to f of x or not equal to minus f of x, then the function is neither even nor odd. So we have already learned that if the function is even or odd by looking at the graph. Now we will learn algebraically. So f of x is equal to x cube minus 6x. So what will I do? I will put f of minus x, which is equal to minus x cube so f of negative x is not equal to f of x. When f of negative x is not equal to f of x, it means or we can just simplify it before giving the answer, minus x cube minus 6x. So f of negative of x is equal to minus, and this term is f of x. So f of negative of x is equal to minus f of x, so this function is odd. Okay, f of negative of x is equal to minus x to the power 4 plus 2 minus x square. So f of negative of x is equal to f of x, so it is even. Okay, we can write it 2 times. Okay, we have calculated f of negative x over here. So now let's compute f of x too. This is this. So f of negative of x is not equal to f of x. So this would be neither, even neither odd. F of negative of x would be equal to minus you can see that minus x square plus 6 is the value of f of x. So f of minus x is equal to f of x. It means it is even. So we have learned that how we can state if the function is even or odd using algebraic techniques and using graphical techniques. Okay. Coming to the problem set 1.2. Given the graph of f of x below left, sketch the graph of the following reflections. Okay, from where are the x values starting? X values are starting from 10. Okay, then x value is going to break at 2, then this next break at minus 2, the next break is at minus 10, and there was 0 2. Okay, for 10 the y value is 4, for 2 it's 2, for negative 2 it's negative 2, for negative 10 it's negative 4, for 0 it's 0. This is the graph y is equal to f of x. Now in the part A we need to do reflection over the x-axis. So how we will reflect this graph over the x-axis? Whenever you have to do reflection over the x-axis, you have to use the ordered pair x negative 5. You have to put negative with the y. So the values of x will come as it is 10, 2, minus 2, 10, minus 10 and 0. But with the values of y you need to multiply minus. So it would be minus 4, minus 2, plus 2, plus 4, 0. So it's reflection over the x-axis. You need to multiply negative with the y. Let's plot 10 on the x-axis, minus 4 on the y-axis, 2 on the x-axis, minus 2 on the y-axis, minus 2 on the x-axis, plus 2 on the y-axis, minus 10 on the x-axis, plus 4 on the y-axis, and 0. So graph will look something like this. Okay, now we have to do the reflection over the y-axis. So for x-axis we need to multiply negative with y. So y-axis we need to multiply negative with x. So y values will come as such, and with x values we will multiply negative. Okay, now let's draw the graph. Negative 10 with positive 4, negative 2 with positive 2, plus 2 with negative 2, 10 with negative 4, and 0. So graph will look like this. The last is 180-degree rotation about the origin. So when we have to rotate about the origin, we need to multiply x and y both with the negative sign. So minus 10, minus 2, 2, 10, 0, minus 4, minus 2, 2, 4, 0. So negative 10 and negative 4, negative 4 and negative 2 and negative 2, plus 2 and plus 2, 10 and 4, 0. Okay, so it is the rotation along the origin. So what we have learned from this is, whenever we need to rotate the graph, reflect the graph along x-axis, multiply the y values with minus. When we have to reflect over y-axis, multiply the x values with minus, and about the origin, multiply both with the minus sign. How we to reflect the graph A to obtain the graph B in each case? Name the type of reflection. Okay, so this is very easy. This is the graph A and this is the graph B. So the type of the reflection is reflection along x-axis, and this is the reflection over y-axis. Okay. Verify algebraically whether each of the following functions is even odd or neither. Okay, again the same one. I'm going to do it for f of negative of x. So f of minus x is not equal to f of x. So answer is neither. Okay, f of negative of x. So f of negative of x is equal to f of x. This is if f of negative of x is equal to f of x, it's going to be even. Okay. If f of negative of x is equal to minus f of x, then it is called odd. F of negative of x is not equal to f of x, so neither. Okay, coming to question number 4. Uses the graph of g of x to answer the following questions. Is this a function or a relation? Okay, so function means it should pass a vertical line test. So it passes the vertical line test, so yes, it is a function. So why it is a function? How do you know? Because VLT passes. Is it 1 to 1? No, because HLT fails. What will be the domain? Domain will be all the x. So it's going from negative infinity to 3, which is not included, then union from negative 3, from negative 3 to positive infinity. Okay, range y values from -3 to the infinity. X-intercept, points crossing the x-axis. Y-intercept, points crossing the y-axis. 1. Y is equal to 1. Okay. State the interval where g of x is increasing. Increasing means going upwards. So this is from -4 to -3 because there is a uncolored point over here. So it's -4 including and excluding -3, union -3 to 2, and 2 is including, union. The next is going to start from increasing from 8 to infinity. State the interval where g of x is decreasing means coming downwards. Two to 7. State the interval where g of x is constant from -4 to -infinity. Relative maximum. This is the relative maximum, that is 3. Relative minimum -2. Absolute maximum, because it's going to positive infinity, does not exist. Absolute minimum -3. G of 0 1. G of -3 does not exist. G of 2 3, where g of x is equal to 1. Zero and 8.3. G of x is less than equal to 0 means below x-axis. -infinity to -3, union -3 to -1, union 4 to 8. -infinity to -3, union -3 to 1, union 4 to 8. Use the graph below to answer the following questions. Okay, so domain of this graph: -2 to 7, 7 to, then 8 to positive infinity, minus 2 to 7, 7 is not included, union 7 to positive infinity, range negative 8 to positive 8, x intercept, crossing at x intercept is 0, y intercept crossing at 0. Interval f of x is increasing, going upwards. Minus 2 to 2, here the graph is increasing, then it's constant, and here it's decreasing, then it's increasing over here again from 8 to positive infinity. So minus 2 to 2 union 8 to positive infinity. F of x is decreasing, five to 7 union 7 to 8. State the interval f of x is constant, 2 to 5. F of x is greater than equal to 0, zero to 7. F of x is equal to 8. Two to 5. The domain of this function is range of this function is x intercept y intercept, interval g of x is increasing from 3 to positive infinity, g of x is decreasing from minus 7 to minus 4, union 0 to 3. Interval g of x is constant from minus 4 to 0. Even, odd or neither. For even the function, by looking the graph we can tell that the graph is even or not, because the graph is not symmetric around the y-axis, so not even, not odd because not symmetric around the origin, so neither. One to one, it cuts 2 points, no. HLD fails. Okay, so verify algebraically whether each of the following is even, odd, or neither. So f of minus 6, which is equal to minus 6, 4 minus x cube, minus 6, 4 minus x cube. So x4 minus x square, f of minus 6 would be equal to minus, this whole portion is f of x. Odd. This is f of negative x. Now let's compute minus f of x, which will be minus x minus x. So f of negative x is not equal to minus f of x, so neither. Okay, so we are done with this unit, in which we have learned about the even and odd functions, and by looking at a function we can tell that either a function is even or odd. By doing the algebraic methods we can tell that whether a function is even or odd. Thank you.